All right, I got two more examples that I want to go through, but these can be a little bit hard, so I'm going to take my time with these last two examples. We're still in 8.1. So this next example here, example 6, the integral of 3x plus 2 over the square root of 1 minus x squared dx. Okay, u substitution would not work as is, because if I let u be the inside of the square root, I do not have its derivative exactly up top. The technique that we're going to do here is that I have two terms up top, the 3x and the 2, and just that single square root term in the bottom. So the technique that we're going to do here is we're going to split up the fraction. We're going to rewrite this fraction into two separate integrals. We're going to do the integral of the first term, the 3x over the square root 1 minus x squared dx, plus the second one, the integral of just 2 over the square root 1 minus x squared dx. Then we're going to try to do these two separately. This first one, this is now going to be a u substitution. I know the coefficients don't match, but it's not the coefficients that are important when it comes to u substitution. It just so that you have the right kinds of functions. If I do let u be this 1 minus x squared in the denominator, then du would be negative 2x dx. And then if I divide that negative 2 over, negative 1/2 du is equal to the x dx. So then when I do my substitution, it's going to be the integral. I still have that 3 floating around, but then the x dx, I'm going to substitute to be negative 1/2 du. And then my denominator would substitute to be the square root of u. Okay, and then we could, pull the constant out if we really wanted to, the negative 3/2. This u in the denominator, I'm going to rewrite it to be u to the negative 1/2, and then we can just do the antiderivative. So we'll come back to this one in a minute. Let's start working on the other one. All right, with my other integral, the integral of 2 over square root 1 minus x squared, I could not do the u substitution for this one. But what I am going to do is that this is going to come from the table. Remember number 18 that we did in the first video? It's rearing its ugly head again. That 2 I could pull out of the integral. And then I have the 1 over a squared minus x squared, where my a is 1 and then the x is just going to be x in this case. So this one we can just go ahead and find the antiderivative of pretty much right away. The 2 we're pulling out of the integral. And then this, we know the antiderivative from that table is sine inverse of x over the a, which is just 1. And then the plus c, but we'll get to that in a minute. So this one's pretty much done. We still have to do this one a little bit. So the antiderivative, we're going to raise that negative 1/2 up to positive 1/2 and then divide by 1/2. Dividing negative 3/2 by 1/2 just cancels out the 2 to be a negative 3. And then we have that u to the 1/2 here. And then substitute back in the u. Remember, it was 1 minus x. So our final answer here is the negative 3. It's going to be the square root of 1 minus x. And then plus the 2 sine inverse of just x, and then plus c. Okay, so again, right, I know I went through some of that kind of quickly, but the main idea here is that anytime you have a fraction, try splitting it up into two separate fractions, which would be two separate integrals, and then doing them separately. Our first integral was just a regular u substitution. Our second integral came from that table, the integral table, and we just got the antiderivative directly. Then you just add the two antiderivatives together. Don't forget to throw the plus c on there. All right, so one of our final techniques here, 6, sometimes split the fraction. Okay, and I got one more example that I want to do here, but this one's kind of hard, so I want to really take my time with this one. So this last example is going to be the integral of dx over 1 plus the square root x cubed. Okay, again, just starting at the top of the techniques, u substitution. It doesn't look like u substitution is going to work here, but it actually does. You just have to kind of do what I call a complicated u substitution. All right, so I'll go slow here. because it's kind of hard to follow, I'm going to let u be the inside of that denominator there, the 1 plus square root x. Still have to find the du. The du, which is be the derivative of this, the 1 goes to 0, but this square root x, you can think of that as x to the 1/2. We would bring down that 1/2 and then take 1 away from the exponent to make it a negative 1/2. Don't forget to throw the dx onto there. Okay, this is where the weird part comes in, because if you look at your integral, we do not have an x to the negative 1/2 anywhere in there. However, if I look at u, it does have an x to the 1/2 kind of in there. So what we're going to do is we're going to multiply this x to the 1/2 over to the other side. It's just square root x. So we get the square root of x du is equal to the 1/2 dx from this line. That's multiplying the x to the 1/2 over. And then what I'm going to do is I'm going to rewrite my u substitution, solving it for the square root of x. If I solve for this square root of x by subtracting the 1 over, I get square root of x is equal to u minus 1, and I'm going to substitute that down here. So instead of square root of x du, I'm going to write that as u minus 1 du is equal to 1/2 dx. Now I can move the 2 over just by multiplying it and write that as 2 times u minus 1 du is equal to dx. All right, we did a lot there. But what's important is this line and this line. That 1 plus square root x in the denominator, I'm going to replace with u. The dx, I'm going to replace with this. So now my integral, I'll copy the integral down here. It was the integral of dx over 1 plus the square root of x cubed. But now it's going to be the integral. Instead of dx, I'm substituting it with this, 2 times u minus 1 du. And then my denominator, the 1 plus root x, I'm going to substitute out with u. So it's going to be that u cubed. Now we're going to use the technique we just did in the last problem, where I have 2 terms up top and a single term on the bottom. So I'm going to break this up into 2 separate things. I have 2u divided by u cubed is going to be 2 and then 1 over u squared. Minus, that 2 is going to be distributed onto this 1, and then I have 2, and then the 1 over u cubed du. Or, if you don't like having the u's on the bottom there, you can think of this as the integral of 2u to the negative 2 minus 2u to the negative 3. So that's just moving the u's up to the numerator with positive exponents. All right, these we can find the antiderivatives for. Not too bad, just raising the powers up by 1 and then dividing. So that u to the negative 2 is going to go up to u to the positive, or to the negative 1, and we're going to divide by negative 1. So that has antiderivative of negative 2u to the negative 1. This negative 3 is going to go up to negative 2 and then divide. Negative 2 divided by negative 2 is positive 1. We have that u to the negative 2. Don't forget the plus c. Now I'd want to fix these, so I'd probably put them back in the denominators. That's negative 2 over u plus 1 over u squared. And then don't forget to resubstitute back in the u. Remember that u, from way up here, was the 1 plus square root x. So our final answer here is going to be negative 2 over 1 plus square root x plus 1 over 1 plus square root x all squared plus c. All right, so like I said, it's kind of a hard one. I know that was weird, and some of it kind of came out of nowhere, but this is what we call a complicated u substitution. You just try the u substitution, even if it looks like it won't work. Try to finagle with your u substitution to solve for dx only in terms of u. Then, when you substitute everything into your integral, you should have an integral that only has u's in it, and then try some of the other techniques. So just going back to my last techniques, the final technique here, complicated u substitution. All right, these should all be fairly old techniques that you guys have all seen before. I did have a couple of other examples, but maybe I'll save those examples for our meetings next week, just so you can see some other things. It's still using these techniques, But there's some other kind of weird stuff that goes on with these techniques. If you have any questions from the homeworks, of course, from section 1 here, just let me know and we'll look at those during our meetings as well.